Let's discuss a question from heat transfer radiation. So what is given is you have a two larger plates, and initially, and there is so this is plate 1, this is plate 2, and there is just the heat transfer because of radiation. So this heat transfer is given for two very large parallel plates. The heat transfer through radiation is given as sigma, the temperature difference, but to the power of 4, by the emissivities is what that matters, and this is what is the emissivities, and emissivities for two plates are given as 0.6. so it is 1 by 0.6 plus 0.6 minus 1, and that comes out to be in the numerator sigma T1 minus T2, but in the denominator you have 2.33. so this is Q. Okay, now what he says is that between 1 and 2, if I keep a plate which is the shield I am calling, and the shield is 3, now effectively there will be some heat transfer from 1 to 3, which is Q1, and from 3 to 2 is also Q1, because it's a steady state, the temperatures have to be maintained. So let's say T1, T2 and T3. so as the temperature of the third plate has to be maintained constant, so whatever it is getting from Q1 from plate 1, it has to give it back to the plate 2. But Q1 and Q1 will be very small, because the emissivity of plate 3 will be very low, and such that Q1 is effectively the heat transfer between 1 and 2 is Q1, and Q1 is very low. And what is given is that it is required that Q1 is, there is a 95% reduction in the heat transfer. So it says that only Q1 has to be 0.05 of Q. That's what it says in the new scenario. And how do I find out Q1 I can use plate 1 to 3 or plate 2 to 3. So Q1, to the same logic if I use, so it is T1 power 4 minus T3 power 4 by 1 by epsilon 1, which is 0.6, by 1 by epsilon, which I need to find out for the plate. Okay, and so this sigma T1 power 4 minus T3 power 4 by 1 by 0.6 minus 1. So 1 by 0.6 minus 1, it will be, if you effectively calculate, okay, let's use it. So 1 by 0.6 minus 1 will come out to be 0.666, so 0.7, and 1 by E I am assuming as K, where I am just calling K as 1 by epsilon, so I will find out K and at the end. So same thing, now Q1 is also equal to Q32 from the diagram. So the same thing I can write between 3 and 2, that is T3 power 4 minus T2 power 4 by 1 by epsilon plus 1 by epsilon 2, which is 0.6. The denominator will be exactly similar, K plus 0.67. Now I know that these two terms are equal, and going by that I can say that T1 power 4 minus T2 power 4 is equal to T3 power 4 minus T2 power 4, and from this, sorry, T2 power 4, so T1, sorry about this is T1 power 3, so this is T1 power 3, and so I can say that T1 power 4 plus T2 power 4 by 2 is equal to T3 power 4. So this is what I can say. This will be useful in my comparing. So okay, so the next thing is Q1 is given as 0.06 of Q, so I'll use this expression for Q1. This and this are related as 0.05, so I'll use Q1 as 0.05 Q. So Q1 I'll use this expression, so that is sigma T1 power 4 minus T3 power 4 by 0.67 plus K, that is equal to 0.05 of sigma T1 power 4 minus T2 power 4 by 2.33. so sigmas gets cancelled out, and we have a relation that T3 we already got by equating heat transfer between 1 and 3 to 3 and 2 in the new case. So using this, the temperatures will go out. I mean T1 minus T3, obviously because T3 power 4 is so it's like everything is in the power of 4. So T1 power 4 minus T3 power 4 should be half of T1 power 4 minus T2 power 4, going by this equation. So I can say that the T3 power 4 is something like midway between T1 power 4 and T2 power 4. So this is 1.67 plus 4, or the best thing is you substitute in place of T3 power 4 this condition, T1 power 4 plus T2 power 4 by 2, and what you get is that you will be getting is that T1 power 4 minus T3 power 4 is half of T1 power 4 minus T2 power 4. So I can say that this 0.05 into 2 by 2.33. So this leaves an equation in terms of K, and so that is the equation for K, and for K whatever you get, and if you inverse it out you will get a value from this. So let's first find out for K you get it something like from this 22.63. so I'll come back here, epsilon is 1 by 22.63 and that value comes out to be 0.04. so the value is 0.04. remember, this is an easy problem. Only thing is you have to just apply the formulas correctly and understand what is given and what has to be found out. So the answer is A. Thank you.